Hello, my subscribers and not subscribers, and friends and enemies and haters, and I'm out of ideas for intros, so let's get started. Last tutorial we finished with this. A bunch of empty game objects scattered around the map, with like a function depending on our width of the chunks. We don't have any chunks on the Y coordinate, so yeah, let's actually do something useful. I was gonna pause it, but sometimes when I pause it, my microphone just glitches. So you're gonna have to stand here and watch me open Visual Studio and see how fast it opens. And here we are. So let me just check what we've done last time. We have here a thingy thing that we call whenever we want to actually generate the map and the mesh and everything. So whenever we generate the map, we want to generate for every single chunk on the Y thing. So let's actually do that. One thing I want to do though, we're gonna do that later. Let's just continue with this layout for now. But I'm gonna change this. I'm totally gonna change this. Everything here is gonna be changed. This is just so we can get something started and have something to work with, just like a start point, eh? So, all right. One thing we should do on the void awake is set up all the maps, all the high maps, initialize everything so we have everything ready to use, and also make sure we get our meshes set up. So how are we going to do that? Well, good question. Not really. We're going to do something like this. So for int, we're going to just do a simple loop. Here we are going to do world dot, I think it's, no, chunk stack. This is where it's chunk stack, and we're going to iterate through that loop. And for every single chunk stack, in this case 10, we're just going to add a new map. It's just new codes, new byte array, isn't it? Yeah, it is a 3D. So width, height, and width. So that should add a new map. There you go, that added a new map. Then we should add the new height map, which is just width by width. So basically, we're gonna use the height map to do our light maps. So I'm gonna use Paint right now to do a quick explanation of how this is gonna work. So let's say we have a chunk here. This is like, I don't know, this is blocks. So we have like some grass here, maybe. So here's the player. One quick way. Let's say, for instance, we are right now adding calculating light for this block right here. One quick way of actually seeing if there is any block on top of it, instead of just like looping for every single block and checking if it is null. Like if we do that for every block on the chunk, it's gonna take too much time to load just one single chunk. So like for instance, on the high map we have like values for every single block, but well, like not on the Y, just on the X and the Z. So let's say we are generating this block, we check if the height map is smaller than this block, then the new height map is going to be the height of this block. So then when we are calculating the light for this block, we know by the height map that the highest block in this column is this one, which is the value that was being stored here. Let's say it's 5 and this is 3, so we just check if the height map is bigger than this, and it means we should be it's a shadow, right? There's a block on top of it, it's blocking light, and light cannot pass. That's the very easy explanation of how the height map is going to be working. And I forgot to make this a list as well. Actually, we don't need to make it a list, since we are only going to have a light map, not a light map, a height map for like X and Z's. We don't need the Y coordinates, so we don't really need to make a height map for every single chunk that's going to be stacking on top of another. And we don't need to put this in the loop, that's just going to take processing time. We don't need a memory crazy shit. Alright. So also what I'm gonna do is I'm gonna do something like this. Public list mesh renderer. Mesh renderer. Meshes. And we're gonna do game object geo, which is equal to new game object. I'm gonna call this chunk stack plus y. I'm gonna say geo.add component mesh renderer. Meshes that add that. We also should add a component that add how's it called? Mesh filter, exactly. Then we should add mesh collide, not mesh collider, no. What else should we add? I think that's it actually. And we should say the material as well. Let's do meshes I that material, it's equal to world that material. I don't know, yeah, that's where you save it. Material static. So then we also want to say that game object that transform, that parent, is equal to transform. So it's going to be a child of our chunk, so we don't have a bunch of flying, like random chunks on the hierarchy. Things are going to be more organized. And I will also want to do something like this actually. Public static transform me. Then I'm going to say me is equal to this dot transform. I don't really need this and transform it. I don't know why I put that there. I'm just going to say transform that parent is equal to world.me. So again, I just don't want to have a bunch of random things here. You can see everything is a child of the world, and every single chunk has its proper chunks, proper column of chunks, however you want to call it. One more thing we gotta do actually before we do that, we're gonna say transform that position is equal to new vector 3. Transform that position that x. Oops. Here I'm gonna say 0. We're gonna change that in a second. Let me just want to get rid of that one. Here we're gonna say y times the height of our chunks. So what that will do is we press play and pause so we can shake things more carefully. We have this, this doesn't really matter, we have then our chunks, which you can see they are indeed stacking upon each other depending on our height that we set on the chunk stack. So we have here 10 chunks stacked on top of another. 0 being the first one and the last one being the one on top. Okay, so whenever we say calculating map, we actually want to calculate the map for every single chunk. So we're going to do another loop. We're going to loop through all the chunk stacks. Let's say I++. So we're going to loop through them. Then we are going to say maps y it's equal to, well, actually we should do something more like this. Byte map, actually it's a 3D array, I keep forgetting, but basically map width, height, width. Then we're gonna do our traditional loop, so x is smaller than width, x plus plus, and we'll do that for all the coordinates. We have y, and finally we have z. And then we just say map x, y, and z, it's equal to something. 0 is going to be air, and then if it is bigger than 0 for now, we're going to say it's a solid block. And then we're going to add different block types, but for now we're just going to work with 0 and 1. Just to keep things simple, again, setting out our foundation, so it's a lot easier then to upgrade from what we will do. And then I just want to say maps y is equal to map. Oops, that's it. Yeah, it's equal to map. One thing I want to do actually. Now, actually, we don't need that. We can find our end world y position, which is equal to y times height plus y. We need to make some parentheses because sometimes, now just to be safe, because sometimes it does addition first or whatever, and yeah. Oh, no, not height map. Height. No! Height. There you go. So, if world position is smaller than 5, we say that our map it's equal to 1, so it's a solid block. We're gonna have basically a flat world. Yeah, that's basically what we're gonna have, a flat world. Alright, so we are generating the map, we are setting the map. This should be quite an easy process since we are not using any paddling noise, it's just doing a straight out flat world. Then on the calculate mesh, we're gonna have to do some more fancy stuff. Okay, so we're gonna have a way to store our vertices and all that for all the meshes. So vertices. I don't know if I'm just gonna call this vert. Yeah. So I want to make a list of a vector-free list, basically, just like so. And vector-free. Since every single chunk will have its own verts list. So yeah. This might be getting a little bit confusing, but we're just gonna have to go for this once, then we are good to go. So just deal with this for now. Triangles, vector 2 UVs. Then we're gonna have another one, which is colors. It's gonna store our light maps. So colors. Did I forget something? Verts, triangles, UVs, and colors. That seems everything. I hope my mic didn't bug. I seriously hope so, because I just got... my sister just came in the room, basically. Anyway. Whew. So I'm gonna say I'm gonna do some new functions. Public void add face, and then I say like top. Actually, I could just do like something like public enum face, and then say like up, down, right, left, front, back, face direction, and then face direction, direction, at face, and then we say like if direction dot it's equal to face direction dot, let's say top. No, I said up. That just changes the top and bottom. Top and bottom. It's usually what I work with. I don't know why I put up and down. I just got confused for a moment there. Shit happens. Okay, so if it is, we are working with a top face, we need to add the top face. I also want to do int chunk ID, which is basically going to be the number, like, which chunk of the stack we're working with. 0 is the first one, and 9 is the one on the top if we're working with 10 chunks. We're going to change that in the future and see, we're going to make the world bigger, because 10 chunks is kind of too small. But we need to first optimize the code a little bit for that to work with a greater number and not start lagging the game. Anyhow, so if we are working with our top face, we say verts dot actually, should we do something now? Okay, verts chunk ID that add, and then we need to add a new vertex, new vector 3. For now, let's just do that. We need to set 4 vertices. So, for who doesn't know how vertices and triangles and all that UV things work, basically, for instance, let's say we are looking this from like, this is like our top view. So we have here like a player. This is their arms. Our eyes are gonna be over there. And the feet are underneath his head. This is his hair right here. Right. So just to give you a perspective of what's the angle that we are currently looking at. So if he had a gun, he would be like something like that, and that's some amazing skills, and he would shoot that direction, for instance. So for us to render like the block underneath him or the block right next to him, this is like at his feet level. We need to set up some things for our graphic cards to know what to do, what to show. So first of all, we need to set the points, which is in this case the vertices. So a plane, a cube has 4 points. I think we all agree to that. You don't see any point here. It's basically where it comes to like this. This is a point. I don't think I need to explain what is a friggin' point. So the vertices are those points. We need to set up these points. So I can have 4 points. They all like 0 counts as well, which is an array, of course. It's pretty simple. So as this is the top face, we're gonna imagine we are rendering from the bottom to up. So we're gonna just say 1, right, and every single one, because we're rendering the one on top. Then we need to, let's say, for instance, this is this point 0, 0, 0. Then we go on the x-axis 1. So we are from this, we came here. Then we need to set up this point, which is x1 and z1. So x1 and z1, and then we need to set up this point, which is basically just z1, like starting from this point, just like so. And then we need to go ahead and set up our triangles. For each like three vertices, like, nah, that's not really a good way to explain. Like, if we want to render a cube, a plane in this case, we can all like just say render all this face into one. I mean, you can use quads, which will allow you to do that, but we are going to use triangles, which is what Unity supports. So we're basically going to separate this into faces, so it makes 2 triangles. And to set a triangle, we need to go clockwise. So we need to set up this one and then this one, I think, or no, this one, and this one. For us to be able to render this face on the direction we want. If you do it counterclockwise, the face is going to be rendering on the other side. It's quite an easy concept if you really get into it. So let's just do the box 6 chunks, chunk ID banner. So basically, we're gonna have 2 triangles, and each triangle will have 3 3 points, which is kind of obvious. So we're gonna go 0. Then we're gonna go. We added this one first, so this is actually. This is 1, this is 2, and this is 3. So we're gonna go 0, 2, 1. And then for the other one, I'm gonna go 0, 3, 2. 0, 3, 2. And this should actually give us some output already. We should be able to see something happening if we actually go and calculate the mesh. So we're gonna do the same thing here. We're gonna loop through all the blocks and all the, well, everything. I'm gonna close everything. This, instead of creating, I'm just gonna say that this is equal to maps, I. And then I'm gonna say if map x, y, and z is bigger than 1. Why didn't this work? Maps if map A is bigger than 1, and map x, y plus 1, that will actually give us some issues. Let's just keep with this for now. Let's go ahead and say add face direction dot top chunk ID is equal to I. Then after we are done with setting the whole faces, we want to go ahead and one thing I'm thinking right now is we don't initialize that. So I'm gonna do something like this. If dot bracket we do dot length, that's dot length, that count is smaller than chunk ID. Actually, we need to see if it's bigger or equal to chunk ID. We're gonna say verge that new that, and then we're gonna do this for all the other ones. The triangles, new list of integers. Then we have the V's. Oops. And finally we have the colors. So we're just making sure that the list exists and we're not accessing something that does not exist. Anywho, after we're done doing that, we're gonna say mesh m, which is equal to new mesh. When we generate this, actually gonna say we're gonna clear every single list. So we need to make sure we don't have that we were previously working with, because that doesn't matter anymore. So we're just gonna clear all those lists. M dot vertices is equal to verts y dot to array dot triangles is equal to triangles y dot to array, and we haven't set anything else, so we're just gonna keep on that. We're gonna say recalculate normals, and then we're gonna say that our meshes y that mesh why can't I do that? Did I mesh renderer? Isn't the mesh renderer the one that holds? I think it's the mesh filter, maybe. I need to change this then. Mesh renderer. I think we actually need the mesh filter to add a mesh renderer. The mesh, it is interesting. Mesh renderer R is equal to that. I said ME, but doesn't really matter. Material. So, because we really need to set out the material. Without that, we cannot survive. Anyhow, that mesh is equal to M. So let's go ahead and see what we have achieved with this. Okay, we got an error. Argument is out of range. Ooh. Okay, so if vertices that count is smaller or equal to y, then I'll say continue, because that means we haven't set any face and we shouldn't really do anything. Anyhow, I'm not seeing anything. That's just sad. No meshes. Let's see, debug.log set mesh. Oh, that's a fail. Yeah, that's a fail. Give me a second. You know why? Because they're saying if it's bigger than 1. I need to say if it's bigger than 0. Let's see if that now does something. Oh, wait. We actually got something. It's all laggy for some reason, but we got something. I got something going on. Shader wants texture coordinates, but doesn't have them. Well, I'm sorry, Shader. I don't have your texture coordinates. Yeah, let's set the texture coordinates and see if it fixes the whole fucking lag. Let's go ahead and add face. Then we're gonna hoe UVs chunk ID add new vector 2 0 0. We need to add for each face. So we're gonna go there, we're gonna go there, and we're gonna go there. I think that's how it's supposed to work. I'm not entirely sure. Damn it. Okay, so we have added that. One thing I've noticed though is that we don't have our X and Y coordinates, and we need those. So we're gonna say int X and Y and Z, and then we're gonna ask the face type, and here we're just gonna say X plus that, Y plus that, and Z plus that. I'm gonna do this for every single one of them. This is a must-have. There you go. And here we're actually gonna do we're actually gonna add this before we add the vertices, so we can do vertices that dot length or that count as you wish. So I think that's gonna work. I don't know if I have to. Let me think. Yeah, it is. It is gonna work like this. At least I hope it is gonna work like that. Oh yeah, and I need to say X, Y, and Z. Oh, what's wrong? Say what? Oh. Of course. Okay, so here we have our flat world. Shader wants texture core. Yeah, I forgot to set the UVs, so it's still kind of messed up. But you can see that we have our little flat world. We're still not doing any cooling, so every single cube that's solid is gonna have a face. So for instance, this cube, like beneath this one, shouldn't be rendering. As you can see, it is indeed rendering. So we're gonna fix that in another tutorial. Now let's go ahead and add. Now we have a lot of time already. Let's go ahead and add the other faces. And when we are good, we're just gonna leave. Let's just make sure. I'm gonna that I set the UVs as well. That UV is equal to UVs. Oops. Y not to array. So this is gonna give us probably a little bit of FPS boost. Yeah. So you can see the texture actually is being reflected on that one. How much does it? Yeah, it doesn't have a camera. I want to see how well it will behave with all these chunks being rendered at the same time. Oh, where are you? Where's the camera actually? Camera, don't run. Okay, so yeah, I can see that it's actually handling it pretty well. Rotation. No, that's not what I meant. I want to look down. Then I want to go up and render every single little piece of detail. And still rendering everything, I'm still having a pretty impressing frames per second. Like, it has a lot of faces for it to render, but it's still handling everything quite surprisingly good. I wanted to try and disable quality. Where is it? Don't sync. Yeah, so you can see it's being pretty quick about that. Yeah, anyways, let's actually do something useful instead of me just rambling. So else if it is the bottom, we just do the same thing, but this plus 0. And here we should just switch these last two faces, so we just switch the direction of the triangle. Else, if it is face direction, not front, we want to go ahead and say z plus 1, plus 1, and here plus 1 if I'm not mistaken. Let's just go ahead and try and render only the mesh actually, not front. Yeah, so calculate mesh. Not front. So just gonna render the front face. Right, so you can see it is indeed rendering only the front face. It's quite weird actually. I'm like walking, it's generating things. It's not really generating, I just cannot see on the other side. But anyways, that's pretty cool, isn't it? Whoa, you cannot see anything from this side. But anyways, then I'm gonna say back. First to test the back side, I'm gonna just do the exact same thing, and then instead of doing x plus 1, just gonna do x plus 0, and then again we're gonna switch the faces so it's pointing in the opposite direction. Then we go ahead and play, and this time it should be the inverse, or it shouldn't be anything. What? Oh, got a little bit away of myself. Yeah, it doesn't need back. I got a little bit too excited there. But yeah, as you can see, it is indeed doing the same thing, but on the other side. Good. Then we're gonna go ahead and add the what's left, the right and the left. So we've done that one, we've done that one, we've done that one, we've done that one. So yeah, I think it's only missing the left and right. So for the left and right, we just switch the X with the Z, Z, or whatever. I want this to be right actually. I'm gonna go ahead and render our right face and see how things will be displaying. It is indeed right. It is quite right. Then we just do the exact opposite for the left face. Here we actually gotta do plus 1. Gotta get. And here we just leave that 0 and switch the direction of the triangles. So yay! Now let's add all the faces and see how everything will look. So the bottom face, right face, left face, and then we're left with what? The back face and the top face. Nope, I already done the top face. The bottom, nope, the front face, there you go. Okay, so we got all the faces there. We should see a bunch of chunks being rendered, some solid cubes. If we go inside it, you'll see that it has way too many faces. They shouldn't be there, but as you can see, we have our flat world. It's not infinite right now, but it is there. If we actually make our map be generated more than, let's say for instance, our chunk height plus 5, you will see, oh, this is actually taking a little bit to generate. Oh snap. Yeah, this is it. Yeah, because we're not doing any cooling. Let's just say 5, just for testing purposes, so we don't get any errors. It's going to be a lot smaller, but that's not what's interesting. The interesting part is you can see our map, it's being applied for every single chunk. For instance, we said that we want our map to be flat, and the chunks are like respecting our boundaries. They're not going more than that, so that's actually pretty good. We've got this to work. In the next tutorial, we're gonna do some face cooling, put up some texture on this, because it's quite ugly like this and quite confusing to say the least. So yeah, see ya in the next tutorial, brother.